This chapter is also known as carbonyl compounds. What is carbonyl compounds? Any functional group in which C double bond O is present, that is called carbonyl compound. So as you know that this aldehyde has C double bond O. So this aldehyde is also carbonyl compound. Then comes your this, which is a ketone, which is also a carbonyl compound. Then comes your RC double bond OH, which is a carboxylic acid, and also it is a carbonyl compound. There are a lot of carbonyl compounds that you can take this, which is acyl halide. Then comes your RC double bond O, OR, which is ester. Then comes your RC double bond O, C double bond OR, which is acid anhydride, which also comes under carbonyl compound. So I hope you are aware of all these functional group, right? Mamuna, Hanifa, and Alan. You all are aware of this functional group. Now, the main point or main topic in this chapter is your methods of preparation. So in methods of preparation, I'm going to take this from aldehydes and ketones. So I'm just going to give you the first one, by oxidation of an alcohol. By oxidation of an alcohol. When you are going to oxidize an alcohol, that you have already studied in the previous chapter, you are going to oxidize an alcohol, which is primary. What will be the product? It will be converted into aldehyde. In the last chapter, we discussed it. And if you have a secondary alcohol, then it will be oxidized into ketone. So secondary alcohol converted into ketone and primary alcohol converted into what? Into ketone. And this should be mild oxidizing agent. Mild oxidizing agent like PCC. And here in ketone, either you can use mild or a strong oxidizing agent. It will be second degree alcohol directly converted into ketone. But if you are going to use a strong oxidizing agent on 1 degree alcohol, it will be directly converted into carboxylic acid. Are you getting my point? This point I already discussed in the previous class. Alan? Is that clear, everyone? So by oxidation of alcohol, you can easily get aldehyde or ketone depending upon the alcohol. If it is primary, then it is converting into aldehyde. If it is secondary, then it will be converting into ketone. Can I change the slide?
Yes.
Okay. The next is basically by hydrolysis of alkenes. If you are going to do hydrolysis to the alkenes, it will be converted either into aldehyde or ketone depending upon the aldehyde. If you have CH2 double bond CH2 and you are going to do first ozonolysis, I'm going to do the not hydrolysis, this is your ozonolysis. Ozonolysis. If you are going to do the ozonolysis, in the first step, you are going to use O3 in the presence of Zn, and then you are going to use H2 water. What will happen? You are going to break this bond, oxygen will be added on this, oxygen will be added in this. So you can see CH2O plus CH2O, that means 2 moles of CH2O, and this CH2O is basically your methanol. 2 moles of methanol you will be getting. In the same way, if you have this CH3CH2, not CH2, and then double bond CH, and you are going to use the same reagent, what will happen? This bond will be broken, oxygen will be added here, oxygen will be added here. So you can see you will be getting ethanol as well as methanol, HCHO. Depending upon the alkene, you can also get ketone as well. If you are going to use O3 in the presence of Zn, and in the second step you are going to do the hydrolysis, what will happen? You are going to break this and this. You can see CH3 double bond O, which is a propanol, which is ketone. So these are some basic, and this is your methanol, which is aldehyde. So if you are going to do the ozonolysis of an alkene, either you will be getting an aldehyde or ketone. That depends upon the alkene. I'm going to directly give questions instead of. Have you revised this? Yes or no? I told you to revise this chapter, aldehyde. Are you done with this? Yes or no?
Yes, sir.
Very good. Now the next is very easy. This is especially the preparation of aldehyde. Preparation of aldehyde. And I'm gonna take it because it's a name reaction which is very important. So this is from acyl chloride, or you can say acyl halide, which is also a functional group, and its name is a Rosenmund reduction, or Rosenmund redux, or Rosenmund reaction, you can call it. Now you can see if you have an acyl halide or acyl chloride, you are going to react this with water in the presence of palladium and BSO4. Then this will be reduced, as you can see. This will be broken, hydrogen will be added here, hydrogen will be added here, and acyl halide will be converted directly into ketone. And this is your byproduct, so we don't need to deal with this. So it can easily be converted into aldehyde, and this is known as your Rosenmund redox. The next we can go for is from nitrites and ester. Just write it. I'm going to give you some question. Everyone is there. Alan, I just my laptop just got stuck. Am I audible?
Yes, sir.
Yeah. Any answer for this? Any answer? Aksa, Alan, Hanifa, Hiba, Mamuna. You are going to break this bond and hydrogen will be added here. So what you will be writing here CH3, CH2, C double bond OH, which has a name propanol. Propanol it is. Now this is your ozonolysis. So you are going to do it. Break this bond O and O, and this will be CH3, CH2, CHO, and this will be C double bond O, and this is your CH3 and CH. So you can see aldehyde and ketone. Now this PCC is a mild oxidizing agent, and this is your 1 degree alcohol. So this will be converted into aldehyde. No one gave any answer for this reactions. Now you can see this is your 2 degree alcohol. So this 2 degree alcohol will be directly converted into ketone. PCC is oxidizing agent, or you can use KMNO4 and lithium aluminum hydride. Is that clear? Can I change the slide? Okay, now from nitriles and esters, there is a Stephen reaction. A Stephen reaction, that means you are going to react this RC triple bond on, which is nitriles or cyanide, with stannous chloride, SnCl2 plus HCl. This is your stannous chloride. And if you are going to react this, first, what will happen? This bond will be broken and hydrogen will be added here and hydrogen will be added here. So you will be getting RCH double bond NH. And this compound is known as imine. And after this, you are going to do the hydrolysis. Hydrolysis has two parts. You know that H2 water has. I'm going to write it like this: OH, and this will be broken. And this hydrogen, as you can see, will be added with this, which makes NH3, and it will be the byproduct, and it will be converted into aldehyde. This is a name reaction which is known as a Stephen reaction. And a Stephen reaction is you are going to react nitriles with stannous chloride. Then you will be getting imine. After getting imine, you are going to react it with water and you will be getting aldehyde. Is that clear? Please do let me know. Now from anhydride ester, you can see this is your ester CH3 CH2 C double bond O OCH3. You are going to treat this with dibyl H, diisobutyl ammonium hydride, its name. And in the second step, you are going to react it with water. What will happen? It will be reduced. Hydrogen will be added here, and it will be converted into aldehyde, which has a name butanol. Is that clear? These reactions are very important. The name reaction. Please do let me know when you are done with this. Everyone done with this?
Yes.
Now, from hydrocarbon. From hydrocarbon, and we are going to oxidize it. So by oxidation, and here oxidation is taking place by the use of chromyl chloride, by the use of chromyl chloride, CrO2 Cl, and this reaction is Attard reaction. This reaction is Attard reaction. So this is here. First, I'm gonna take toluene CH3. First, you are going to react this with CrO2 Cl, which has a name chromyl chloride in the presence of CH2. So as you can see, two of the hydrogen will be removed and it will be replaced by ORCO. Add by, basically it addition takes place. OCRO HCl. Actually, what happens, you can see this term, this is CrO2 Cl2. You can see Cr, then O2, and then Cl2. Hydrogen is gonna add with this. This CrO2 Cl2 is gonna add with this, and two hydrogen will be there. So it will be twice. And after this is your chromium complex. This is your chromium complex. And after getting this, you are going to do the hydrolysis in the presence of acid. Then it will be converted into benzaldehyde. Then it will be converted into benzaldehyde. Now I'm gonna, instead of covering this, what we say, the theoretical part that you already know, I'm gonna give some questions. Everyone done with this? Mamuna, Aksa, Hanifa, Hiba, Alan.
Yes, sir.
Okay. So you are going to solve the question number 1. What is that you are going to do? No. Hanifa, you are close, but not right answer. See what will happen. If you are going to react the CH3Cl with Cl2, what will happen? This chlorine will be attacking at singly bonded carbon, and one of the hydrogen will be replaced with the chlorine. So it will be generally, the students think that this will be the answer. No, because for this reaction we want X. So basically, if you want to take this and you are going to do the hydrolysis, you know what will happen? You will be getting this product. You will be getting this product. This Cl will be replaced by OH. This Cl will be replaced by OH, and you can see this is your alcohol, not aldehyde. We are going to make aldehyde. So what I'm going to do, again, I'm going to react this Cl with Cl2 in the presence of H nu, and then we will be able to get, you can see this will be your CH and this will be your CH2. And if you are going to do hydrolysis, both the chlorine will be replaced by OH. Both the chlorine will be replaced by OH, and that means one hydrogen will be there, and OH here and OH here. Two OH group on a single carbon is unstable, and that's why H2O will be eliminated. and hence H2O will be eliminated, then there will be formation of benzaldehyde. And that's why the X is basically this CH. So the answer is B. Is that clear? This reaction 100% from NCRT. This reaction, after retarded reaction, there is a reaction, which is quite easy. Is that clear, everyone? Please do let me know. Alan, Mamuna.
Yes, sir.
Okay. Now question number 2 you are going to do. This is your option. See, option A is here. Reaction by which benzaldehyde cannot be prepared. We know that we prepared from here, which is Rosenmund reduction. This Cl will be replaced by hydrogen. So this is true. This is Gattermann-Koch reaction. Gattermann. So CHO will be added here. So this is also true. Now, if you are going for this carboxylic acid in the presence of this, it will give you, what is this? You can see, first of all, this is your attard reaction. This is your attard reaction. So this is also true. This is not true. This is not true. So this will not be the answer. Is that clear? This is your Clemenson reduction. Clemenson reduction, which give you hydrocarbon. So the answer is C. You cannot make aldehyde from benzaldehyde from this reaction. Are you getting my point? Yes or no? Alan, Mamuna,
Yes, sir.
Hiba, Alan, did you revise all this reaction from the previous class? Like I told you to read about aldehyde. Did you do that? Yes or no? If you
Not
didn't
much,
do,
sir.
what do you say? Did you revise that?
No, sir.
No, sir. Okay, what about you, Mamuna? Did you revise? Hiba, Hanifa?
Yes, sir.
Okay. Do question number 3. Question number 4. If we will not revise, then we will be only covering the, what we say, theoretical part. We will not be able to do the questions, and that is very bad. That's good. What is the name of A? Aksa. Very good. Any answer for A? Sorry, third. You can see this is your acyl halide H2 in the presence of PDSO4. That is your Rosenmund reduction. Rosenmund reduction, and you know that this is your benzene, which has a formula C6H5. Cl will be replaced by H, so I'm gonna write C6H5CHO. So the answer is D. Which of the following reactions will not result in the formation of carbon-carbon bonds? See, it's very easy. Okay, let me explain this. There is an important reaction. that is aldol reaction. Aldol. See what is aldol? It's very easy. First of all, for aldol, there must be at least one alpha hydrogen. At least one alpha hydrogen there must be. And this carried out in dilute alkali or dilute NaOH or KOH we use. Dilute sodium hydroxide or potassium hydroxide. See what will happen. It's very easy. If you are going to do the aldol reaction of this what ethanol. So first you are going to check the whether it is having an alpha hydrogen or not. So I'm going to write it like this: CH3 C double bond O and H. As you know that this is your main functional group. So this is your alpha carbon and hence it has 3 alpha hydrogen. That means aldol reaction will be taking place. Aldol reaction will be taking place. So after doing this reaction, you will be getting A. And after getting A, you have to do the condensation and you will be getting B. You will be getting B. First of all, you are going to take 2 mole of this. I'm going to directly give you a simple trick to solve this. What you need to do. And whenever only one type of reactant is there, this is known as self-aldol. Self-aldol. And if you have 2 different types of aldehyde, then it is cross-aldol. Like ethanol, propanol, that is cross-aldol. So see what I'm going to do. This is known as aldol condensation. Aldol condensation. And this is the product that is known as aldol. This product is known as aldol and this product is known as aldol condensation. So what you need to do, there is 2 mole of this. So I'm going to take 1 mole of this like this CH3 C double bond O and H is there. See how I'm going to write. First mole I'm going to write like this and the second mole of this I'm going to write like this. I'm going to write like this. Why I wrote it like this? First, you are going to take one mole of this and show the double bond O here. And the second mole, you are going to write in this way to show the 2 alpha hydrogen in this way. Actually, you need to remove H2O. And this H2 must be from alpha hydrogen. This must be alpha hydrogen. Are you getting my point? This must be alpha hydrogen. So you will be getting CH3 and you can see this is your C and this is your H, which will be doubly bonded with this CH and it will be CH. The product that you have got this product is actually your aldol condensation. Condensation, that means you are removing water. So it is your aldol condensation, that means B. Then how will you be able to calculate the aldol product, calculate the A product? It's very easy. You just removed water. Now you need to add water. Now you need to add water. And you can see if you are going to add water, water has 2 parts, H plus and OH minus. This is 2 parts. Now, this is your main functional group. So this will be your alpha, this will be your beta. Always add OH minus to the beta carbon and H plus to the alpha carbon and break the bond. So you can see this will become CH3C and it becomes CH2 and there is CHO. So this will be your A, which is aldol product. Are you getting my point? You are going to have 2 mole. You are going to have 2 mole. 1 mole you are going from 1 mole you are going to remove oxygen and from another mole you are going to take alpha hydrogen, 2 alpha hydrogen, so that you will be able to remove water. If you are going to remove water, you will be getting a product that is aldol condensation because you are getting it from removing or eliminating water. So what will be the aldol? You can see why its name is aldol. You can see there is aldehyde, so ald, and there is alcohol, so aldol. And its name is aldol condensation. This is also aldol, and since we did condensation, that's why its name is aldol condensation. Is that clear? Please do let me know. No one is speaking at all, responding at all. Are you done with this?
Yes.
Okay. Now I'm gonna give you the similar question on this. Then we will move to the cross side. So I took ethanol. I'm gonna give you propanol. Please do the aldol condensation of this. The reaction will take place in dilute this. Are you done with this? See, this is your main functional group. So this will be your alpha carbon. So it has two alpha hydrogens. First, what I told you, it's very simple. First, you are going to show the oxygen part. So it will be like this. And in the second, you are going to show the alpha hydrogen. So I'm going to take it like this. And this CH2 is connected with CHO. So I'm going to write it like this. And this CH3 is this. So I'm going to write it like this so that I will be able to show you the removal of water. So if you are going to remove this, you will be getting a product that is, this is your aldol condensation product, CH3, CH2. Then comes your CH, double bond. Then comes your CCH3, CH. This will be your aldol condensation. To do HOH, HOH, and you know that this is your alpha, this is your beta, and this is your beta. I told you add OH to the beta, not to this, to the doubly bonded carbon. So you are going to bond it to this doubly bonded, and this will be going to this. So this will be your aldol product, the first product. So I can show you CH double bond. Now it is single bond, and this is your CH3, and then this is your CH. Isn't it easy? Yes or no?
Yes, sir.
Can I change the slide?
Yes.
You can easily calculate the, if you can find the alpha hydrogen, you can do the same. Now I'm going to give you ketone. Ketone is in the same way. Please do this. Dilute NaOH. You just need to remove water. Let me know if you're not able to solve this. Mamuna, are you able to solve this? Eba? Everyone is done with this. Okay, now you see. No answer. You are going to write in this. So that it will be easy. Okay. And this is your alpha and this. So you can take either one of them. So I'm going to write it like this. Just wait a minute. C double bond O and CH3 will be here. And you are going to remove this. Just wait a minute. And then water will be eliminated. And you will be getting directly. Oh, I'm going to write in this C double bond CH and there is CH3 and there is CH3. And then comes your C double bond O CH. And this product, since ketone is there, aldehyde was there, so we were saying aldol, and this will be ketol, ketol condensation, because we just removed water, so it will be ketol condensation. And if you want to get ketol product, so HOH, you know that this is your main functional group alpha beta. This is also your alpha, but you are going to take here only where double bond is present. And you will be getting CH3 is there, CH3 is there, and then OH will come at beta, and then single bond it becomes CH2, and then C double bond O CH. Is that clear, everyone? No, please do respond. Can I change the slide? This is your ketol product, and this is your ketol condensation. Now I'm gonna ask you about an important reaction, which is Cannizzaro. Cannizzaro reaction, to recognize, first of all, there should be no alpha hydrogen, and second, the reagent is concentrated alkali, that means concentrated HNaOH or KOH. So if you have given an aldehyde like this, you can see there is no alpha carbon. You can see this is your main functional group. So to the carbon it is connected. To the carbon it is connected. That is your alpha carbon, and there is no alpha carbon, so there is no alpha hydrogen, no alpha hydrogen. So first of all, if you are going to react this, with concentrated NaOH or KOH, what will happen? This will first reduce, since it is an aldehyde, then it will be reduced into methanol alcohol, and this will be oxidized into aldehyde oxidizes into carboxylic acid. So this will be oxidizes into carboxylic acid salt. It will not be oxidized into carboxylic acid, but it will be oxidized into carboxylic acid salt. If you are going to take Na, there will be Na, then it becomes carboxylic acid. It's very important. The aldehyde which has no alpha hydrogen and treated with the concentrated NaOH or KOH is a Cannizzaro reaction. First, you are going to reduce it. There will be two products. First, one will be reduced and another will be oxidized. So I'm going to give you a question on this. So this is your aldehyde, and if you are going to treat this with concentrated NaOH or KOH, you can take. You can see. I'm going to explain. This is your main functional group. So this is your alpha carbon. And if you will look at the alpha carbon, there is no alpha hydrogen. As you can see, this carbon is making 4 bonds, so 0 alpha hydrogen. That means it can show Cannizzaro reaction. So first of all, you are going to reduce it. So this aldehyde will be converted into alcohol. This is the first product. And again, this aldehyde will be converted into carboxylic acid salt. So you are not going to write hydrogen here. You are going to take the metal from here. So this will be the product for Cannizzaro. Is that clear? No one is responding at all.
Yes, sir.
Okay, Mamuna, thank you. Iba, Aksa, and Hanifa. इन्हें रोजा लग रहा. Can I change the slide?
Yes, sir.
Now moving to the question that I gave to you. Which of the following reactions will not result in the formation of carbon-carbon bonds? That is Cannizzaro reaction. As you can see, in Cannizzaro reaction oxidizes and reduces. So there will be no formation of carbon-carbon bond. That's why it is Cannizzaro reaction. If you have remembered, this is your C double bond OH. So this will be converted into CH2OH. There is no carbon-carbon bond and it converted into carboxylic acid salt. So that's why the answer is. Now I'm going to give you some questions on this. Please do question number 10. Please do question number 11. Whoever got the answer, you can either chat, send me the answer in chat box, or either you can directly tell me. This question number 10 reaction we have already studied in the previous chapter. Any answer for the question number 10? Reaction between acetone and methyl magnesium chloride followed by hydrolysis will give secondary butyl alcohol. And I think it's wrong answer. Was this Iba? D. Oh, Iba good and Hanifa wrong answer. So as I told you, when RMGX, that is your what it is Grignard, going to react with ketone, it will always give you tertiary, tertiary alcohol. So which one of tertiary butyl alcohol? You can see directly tertiary is there. That's why it is butyl. Uh, it is the answer. Is that clear? I told you when methanol react with Grignard, you will get 1 degree alcohol. And I also told you every aldehyde except methanol gonna react with Grignard, then you will be getting 2 degree alcohol, and when ketone will react with Grignard, then you will be getting tertiary. Question number 11, please. Reaction between benzaldehyde and acetophenone. So first of all, you need to know about the structure of this. This is your CHO, and acetophenone has an structure like this. You can see acetophenone has an structure like this, and this is treated with NaOH. NaOH. So first of all, you need to see dilute NaOH is there, right? In question, it has been written dilute NaOH. So there must be something that is in our mind. That is your very good Aksha. It is aldo. Now you can see this has an alpha hydrogen and both are different. So it is cross aldol. Condensation. First of all, Cannizzaro reaction, there is no alpha hydrogen and treated with concentrated base. There is no alpha hydrogen treated with concentrated base, different molecules, that is cross Cannizzaro. Cross aldol treated with dilute NaOH, same molecule. Treated with dilute NaOH and different molecules. So the answer here will be the cross aldol condensation. Is that clear? Now moving to the next, that is your first of all read the question and then consider the reaction, and this is the reaction. Identify silver mirror observed. Please do it. A is giving silver mirror test. Am I audible clearly?
Yes, sir.
Okay. First of all, C2H6O. You can see this is your tolerance reagent. Tolerance reagent is basically gives test for aldehyde. So this should be aldehyde, and you can see copper in the copper at 573. That means this is your alcohol. This reaction we have studied in the previous classes. Heated at this, so it will be converted directly oxidized into aldehyde. If it is an aldehyde and you are going to react this with Ag NH3 silver mirror observed. So I'm going to show you this silver mirror observed. That means Ag will be precipitated. Here the Ag oxidation state of Ag is +1, and now it is what we say Ag is basically precipitate form. Now you can see A, you are going to react with OH minus and heat. A, that means ethanol, you are going to heat it, then you will be getting Y. What is Y? And we need to also tell you. First of all, A is ethanol. No, not A is ethanol, not ethanol. A is ethanol alcohol. Oh, wait a minute. I just confused. A is your ethanol, that is good. X is your ethanol, and then comes your, if this is your ethanol, then you are going to treat this with base and heat. What will happen then? base and heat. This is your dilute. That means aldol is taking place. So, and heat you are doing, that means aldol condensation. So we already did it. So this will be the aldol condensation. I'm gonna tell you, show you. This will be your aldol condensation. So this will be your Y butyl, and you can see if you are going to react this with NH2. So it is carbazone. How I got it? So I'm gonna show you the reaction here. See, this is your CH3 C double bond O, and this is your H. And now I'm gonna show you this NH2. I'm gonna write H2N and then NH, and then C double bond O, and then NH2. So first you are going to just remove the water and this is what known as, this is known as semicarbazole. Is that clear, everyone? So it will be basically CH3, CH double bond, and then N, and then NH, and then comes your C double bond O, and then NH. This is known as your semicarbazole. So it's very easy. First one is basically you are going to oxidize it into alcohol, treating with tolerance reagent, and then this A you are going to treat with base in the presence of heat, then it will be aldol condensation, and you are going to treat this aldehyde with NH2 NHC double bond O NH2, and you will be getting semicarbazole. Is that clear, everyone? Can I change the slide?
Yes.
Okay, come to question number 6. Look at the question number 6 and let me know. Question number 6, 7, you are going to tell me. Please do question number 6 and 7. Question number 6 is quite easy. No answer. Six and 7 is quite easy. Well, for 6 it is B. You have written, and so please do write the question number as well. If I'm giving you two options, two questions at the same time. Okay. So for question number 6, you can see this will be reduced into RCH, oxidized into aldehyde, this, and then reduced basically. Then this catalyst of Rosenbond reduction, you know that this will be the answer. Very good, Alan. Just wait a minute. I'm going to give you a very easy question. Please do this question number 20. It's very easy and important. Which is most reactive towards nucleophilic addition reaction? Very good, Alan. Oh, not a Mamuna. You can see nucleophilic addition reaction. That means nucleophile is waiting to attack. So as you can see, there should be some nucleophilic, that means electron rich. So if you are looking at this, there is plus I effect, which is increasing electron density here, and nucleophile does not want electron, it will give electron. CHO is there. So CHO is almost common in everywhere except this. In nucleophilic addition, this is lowest because alkyl group, bulky group is there. So only the group that is left, you can see this due to NO2, this shows minus M and it decreases electron density. Electron density decreases and hence nucleophile can easily attack on this. So because there is deficiency of electron in this room due to this NO2, so the answer is D. Is that clear? Mamuna?
Yes, sir.
No. Now you are going to tell me about this, the order of stability of following tautomeric compounds. Tautomeric compounds, it's very easy. You just need to do 1, 2, 3. You just need to remove this hydrogen to this and remove this double bond to this. So it becomes ketone. Now the second one, wait a minute, is it missing? Just wait a minute, please. Okay. Okay, we can. Okay, there are three compounds that is given. You need to tell me which one is more stable and you can do this. Very good. The answer will be simple A. Very good. Both of you. Hiba, no answer from you. Hiba, are you there? No. Predict the product in the given reaction. That means this is your reactant. I'm gonna show you all the. Just wait a minute. This is your question number 22. Please do let me know the product. 50% KOS, that means it is concentrated acid, base, concentrated base it is. So any aldehyde which has no alpha hydrogen or zero alpha hydrogen treating with concentrated base is your Cannizzaro reaction. I just gave you a hint. Just let me know the answer. Cannizzaro reaction. A is the wrong answer. How can there will be two carbon? Only one carbon is there now, right, Alan? How can you increase number of carbon? You can see this will be reduced, so it is reduced to alcohol, 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 and this will be oxidized to carboxylic acid salt, C double O negative and a positive. There is no metal given, so what you need to do, just remove this C double O negative. So it will be oxidizes to C double O negative. So this is wrong. This is also wrong. This is right. This is right. So as you can see, what was there? Cl was there. So we need this Cl, not OH. So the correct answer is C. Very good, Mamuna. Is that clear, Alan?
Yes, sir.
Okay. Now you are going to tell me about the question number 28. Very easy. The order of reactivity of phenyl magnesium bromide with the following compounds. You have PHMG, MHB, MGBr. Very good. Was this Alan? Right? Very good, Alan. See, this will go like this: negative, there will be positive, there will be negative, there will be positive, there will be negative, there will be positive. Now you can see pH is already a bigger compound, so it will be attacking here, and it will be attacking here, it will be attacking. Now aesthetic hindrance will be there, in which the aesthetic hindrance will be lesser here, because it has the smallest group, so it will be the most reactive. Then you can see CH3, here it is pH, that means benzene CH3 pH, so it will be the second. So the answer is D. Is that clear? Is that clear?
Yes, sir.
Okay. Now this is the question. Following compounds are given. Following compounds are given. This is the question 29, which is very important, and it comes from iodoform test. Which of the above compounds, on being warmed with iodine solution and NaOH, will give iodoform? Which one will give iodoform? Does anyone know what is iodoform test? So I'm going to tell you. If methyl ketone is present, if methyl ketone is present, am I audible?
Yes, sir.
Uh, am I audible? Aksa,
Yes,
Alan,
sir.
Yes, sir.
Mamuna.
Yes, sir.
Okay, so in this iodoform test given by methyl ketone. Methyl ketone. So you can see this is your methyl ketone. So this is your methyl ketone. So this is your methyl ketone. So you can see this is your methyl ketone. So 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 your methyl ketone and also methyl alcohol like this or this ethanol. Iodoform does not given by this methanol. So the answer will be 1, 2, and 3. Always remember that this will be the scenario. Methyl ketone will be there. So this is it for today. In the next class, you